Hello, this is the first of our videos covering what you need to know on MATLAB for EG168. So to start with, let's go over the basics. When you open MATLAB, you will see this graphical user interface. The current folder contents is located on the left. The current folder location is just above it. The command window is in the center. The workspace is on the top right. This shows what variables are currently stated in MATLAB. These can be viewed by double-clicking on the variable name and can be inserted into command window by dragging them across. This will save you from having to re-enter it. Then the command history is located just below the workspace. This shows the full history as what has been typed into the command window throughout your session. And to save you from having to retype any of these commands, you can just drag those across and re-enter them. If you ever need help in MATLAB, you can either refer to these videos or you can go to the MATLAB help webpage. This can be accessed at uk.mathworks.com/help/MATLAB. And you can type in whatever issue you are having in MATLAB or whatever operation you are looking for. Another good source of help can be found by the recommended text. This is MATLAB, A Practical Introduction to Programming and Problem Solving by Stormy Attaway. This can be found in the Bay Library, and there are multiple versions available, including an online access version for those who aren't so keen on books. Now, for getting started, it is best to become familiar with the basic mathematical operations, such as brackets. So, I'll give you a few basic examples. Orders, so 6 to the 8. Divisions, so 100 divided by 3. Ooh. That's the beauty of MATLAB as well. Even if you get it wrong, it will tell you where you've gone wrong. Although if you've left a full space out of a rather long sentence, well, just be careful with what you type in. It's not very fun having to go through something and looking for a full stop. I can tell you from experience. So 100 divided by 3. Multiplication, let's go for 80 times 70. Addition, so 23 plus 98. And subtraction, so 45 minus 67. In addition to that, the next thing to look at are the variables and functions. By assigning variables, you are allowed far greater flexibility in calculations than you would using, say, a standard calculator or even Excel, since this is a little more intuitive in certain ways. However, these variables must start with a letter and contain no spaces, and they are very case sensitive, so once again, going back to the full stop, make sure everything is spelled correctly, or just go back to the workspace and drag them across once you've wrote them out to avoid just any mistakes. So let's give us an example. Let's go for force in newtons equals 70 and area in meters equals 67. In this case, the equal sign doesn't just mean equals. It in fact means assigned to. So the set variable name is assigned to the expression, with the variable name always being on the left and the expression should always be on the right. But just to show you what I mean, if we have area in meters equals area in meters plus 5. What we mean here is that we are assigning a new value of area to the old value of area plus 5, which is 72. And just to show how we can save our time by not having to type something in again, we shall now try calculating stress in pascals equals, now once again, I'm too lazy and don't want to get anything out of place, so force divided by area. There we have the stress. Now moving on, MATLAB has some pre-stated variables such as pi, I, J, EPS, real minimum, real maximum, and infinite, or INF. However, you should be aware that if you were to overwrite any of these values, sorry, tongue's a bit twisted, you would then have to reset the program in order to get back to the original value. So if you ever feel the overwhelming urge to assign j to a new value or pi to a new value, you're going to lose most of your work and have to reset it, so please don't do that. Moving on, as well as this, MATLAB also has inbuilt functions for common mathematical expressions such as square roots. So let's try 296. As well as trigonometric functions of sine, cos and tan, which you can do in degrees. So let's try sine d20. You can also do it in radians. As well as the inverse trigonometric functions in both sine and radians. So we'll try that again. And once again in radians. There we go. It should also be noted that if you make multiple commands, you don't always have to have all of the values displayed. So in order to save time, we can use a semicolon after the expression. So in the case of a and b equals c, let's try and only show the value for c. So it's a equals 3 plus 5, semicolon, b equals 4 to the power of 6, semicolon, and c equals a plus b. There, we only get the value for c and we save time. This is quite good with far longer and far more complex equations. And so that brings it to the end of our introduction. The next video will be looking at the remainder of chapter 1 on vectors and matrices. Thank you for listening.